Okay, good morning. Welcome to day 2 of the Aquifer Storage and Recovery Peer Panel Review Kickoff Workshop. This is a meeting with the South Florida Water Management District and the Army Corps of Engineers and a panel of experts, eminent scientists in the field of South Florida geology and ecology and chemistry. And we are continuing the workshop that began yesterday regarding various aspects of ASR technology and ASR science. If anyone is interested in viewing yesterday's presentations and discussion, that meeting will be recorded and we can share links to the entire presentation and conversation and discussion that took place yesterday. That link will be available probably in the next couple of days from our technology staff. But today we're going to begin again with various presentations on aspects of the ASR program that we're getting ready to implement. And before we start, just to let you know that the discussion is going to go today from 9 till roughly 11:30 with the ASR peer panel and the participants, and then at 11:30 we will open the meeting up to public comment, and we will go from 11:30 to 12 o'clock and end at that point in time. So without further ado, I'd like to have the panel members just please introduce themselves again to let the public know who is at the table with us today.
Hey, good morning. My name is John Arthur. I'm the chair of the peer review panel. I also serve as the state geologist of Florida and the director of the Florida Geological Survey, which is a division within the Florida Department of Environmental Protection. And I've been asked to serve on this committee because of my background in aquifer storage and recovery, primarily from the hydrogeology and geochemical side. Our research team at the FGS did some of the preliminary and along the path of the Everglades restoration over the early 2000s, looking at water-rock interactions, release of metals, as a result of ASR, and also trying to understand, how to mitigate that process. And I've served on a few 4 National Academy of Sciences committees focusing on either habitat restoration and the hydrogeological components of that, or more specifically aquifer recharge. And presently I serve on the Water Science Technology Board at the academies. And with that, I'll pass over to Sam Upchurch.
Good morning. I'm retired, but seem to keep working on these things. I'm a trained geochemist, have done quite a bit of work on the geochemistry of aquifer storage and recovery systems. I'm also consider myself a karst specialist, and as such, spend a lot of time dealing with understanding porosity and fracturing and other things in limestones. I'm a former professor and chairman of the geology department at the University of South Florida, and for the last few years a consultant, and I'm also the senior author of a new book, The Karst Systems of Florida.
And it is a fantastic book. We'll go over to Reed next. Reed Heil.
Hi, I'm Reed Heil. I'm with the Florida Fish and Wildlife Conservation Commission in the Fish and Wildlife Research Institute. I've been brought onto this committee because my background is primarily in fish population dynamics and fish ecology. I've been doing work on the Upper St. Johns River for 16 years, so I'm fairly familiar with water resource issues with regard to the St. Johns River Water Management District. And for the last couple of years, I've been moving south into the Kissimmee Okeechobee watershed. So hopefully I can provide some input on the fish side of things with the water going into the pipes and coming out of the pipes down the road.
You're muted, Tom. There you go.
I'm Tom Missimer. I'm at Florida Gulf Coast University, where I serve as the director of the Eminent Technologies Institute. I'm also eminent scholar in hydrology in the College of Engineering. I have been involved with ASR for a long time. I wrote a book on ASR with my colleague Bob Maliva. It's one of 11 books that I've written. I also served as the chair of the Technical Advisory Committee for the Governor's Commission for Sustainable South Florida in helping draft some of the initial language in the SERP plan, including we produced a report on ASR back in those days, far less sophisticated than what is done today. And also I serve on several advisory councils for the National Water Research Institute, particularly the Hampton Roads ASR system, which will be the second largest in the United States. It's $1 billion project in Virginia.
All right, thank you, Tom. And Renee Price.
Yes, I'm Renee Price, a professor and former chair in the Department of Earth and Environment at Florida International University. I'm a chemical hydrogeologist, and I also served on the National Academy's review panel of the Everglades Aquifer and Storage Recovery study that was published in 2015.
All right, well, my thanks to the committee for the introductions, and Bob, will turn it back over to you.
Okay, thanks, gang. Okay, well, I just wanted to have the various members of the ASR team here at the South Florida Water Management and the Army Corps of Engineers also just give a quick introduction of themselves so that folks know who we are. Again, my name is Bob Barastro. I'm a hydrogeologist working to essentially help out in the ASR program here at the South Florida Water Management District, and I've been involved in the ASR program for the last 20 years. Michelle, you want to go?
Sure. Good morning. My name is Michelle Furry, and I'm the district's project manager for the SERP Lake Okeechobee Watershed Restoration Project. I've been with the district for about 16 years. And as we discussed yesterday, and we're going to continue with today, the ASR wells are a major component of the SERP Lake Okeechobee Watershed Restoration Project. Now I'll turn it over to Jennifer Gent.
Good morning, everybody. My name is Jennifer Gent. I am the project manager for the engineering and construction side of the project. So as we've put together a plan, I'm responsible for going out and making sure we get all the contracts and we have all the people there and to manage the contracts while it's getting underway. I look forward to telling you guys a lot more about the ASR projects and what we're moving on in the near future on later today. How about you, John?
Okay, I get.
Okay, hey, this is John Shaw. I'm principal hydrogeologist, the Water Supply Bureau at the district, and been working on the ASR quite a bit. So with that, I think Emily was getting ready to join in. Emily?
Emily Richardson, also hydrogeologist with South Florida Water Management District, working on ASR project for about 2 decades also.
How about Liz? We left her out.
Hey, good morning. I'm Liz Kaneha. I'm a project manager in the Everglades and Estuaries Protection Bureau at the South Florida Water Management District. I've been working at the district for about 8 years now, and prior to that, I worked in environmental and in engineering consulting for about 10 years. Here at the district, I provided assistance with the planning effort on the Lake Okeechobee Watershed Restoration Project, and also providing support now on the ASR program implementation.
Anybody else at the district want to introduce themselves? Okay, how about at the Army Corps of Engineers?
Hi, this is June Marecki. I'm the engineering technical lead for ASR in the Corps. I've been with the Corps since 2001 and working on ASR projects since then. And prior to that, I worked on ASR projects with the U.S. Geological Survey in South Carolina and elsewhere since 1994. Now I'll turn it over to Robert Carroll.
Hey, this is Robert Carroll. I'm a geologist with the Army Corps of Engineers, Jacksonville District. I've been with the Corps for about 18 months now, and I am just learning a little more about ASR. Obviously don't have as much experience as the rest of everybody else, but that I will throw it to Tim Geisen.
Tim, are you on the line?
Okay, can you hear me now?
Yes, we can.
Sorry about that. I unmuted my phone, but not on the computer. Good morning, everyone. My name is Tim Geisen. I'm the project manager for the Lake Okeechobee Watershed Restoration Project for the Corps of Engineers. I've been at the Corps for a little over 20 years, serving as in water resources and engineering, and then in project management for the last 4 years. Background in environmental restoration projects, including Kissimmee River restoration and multiple SERP projects.
Morning, Tim.
Good morning. I think that is everyone from the Corps that's on the line.
Okay. All right. Well, without further ado, what we thought we would do was just chat a little bit about what happened yesterday, and some comments and discussion about everything that was included in day one. John, did you wanna lead off with any high level conversation?
Hey, Bob, sure. Well, yesterday we did indeed, am I unmuted? Hang on.
We can hear you.
Okay, good, thanks. I've got multiple platforms going here. Yesterday we did indeed have a marathon of PowerPoints to review many aspects of the Everglades restoration to date, with a bit of a glimpse into the future regarding some studies, including a fascinating and scientifically interesting look at the water rock microbial interactions and their role in nutrient uptake. And it was indeed a tip of the iceberg of the mountain of research that's been completed by numerous teams at the district, the Corps, consultants, USGS, FGS, et cetera. And we have wonderful context to look forward in terms of, what are the current plans, which I think we're going to hear about today, and inform this peer review team as we move forward with making some recommendations. I have 4 pages of notes from the team that I've compiled last night, looking at considerations related to hydrogeologic modeling, geochemical considerations, ecosystem and biological, well construction, ASR site-specific comments, and even operational considerations. So our minds are already grinding in on this, and we look forward to hearing what the day brings. Back to you, Bob.
Okay, thanks. Yeah, I've got a couple of pages of notes myself, and I think we heard some really compelling ideas and thoughts of things that we ought to be taking a look at as we implement the ASR program over the next couple of years. So, thank you for that. I do believe that we're gonna get a lot more as a result of what you hear today. So, we did get a great bit of conversation going, actually prompted, I think, by Sam Upchurch about he wanted a little bit of the background of the benefits, the actual direct benefits of ASR, and how they would directly implement effects to the lake and to the estuaries, and how it all sort of plays together. And so at the beginning of yesterday, we did hear from Michelle Faree about what the essence of the Lake Okeechobee Watershed Restoration Plan is. But what I did ask her to do today was just kick off the meeting again with a little bit more of the details of the actual direct metricized benefits of ASR and the Lake Okeechobee Watershed Plan, so that you get a little bit of a broader view of what the entire project will provide for the South Florida ecosystem. So, Michelle, would you like to start your presentation here now?
Sure. Thank you, Bob. Can you go on to the first slide?
Yeah.
So just to provide a quick recap from yesterday, you saw the slide yesterday. Just a reminder, the Lake Okeechobee Watershed Restoration Project is a SERP project that focuses on storage features north of Lake Okeechobee, and it includes three major components. It includes above ground storage, ASR wells, and wetland restoration components. And Bob, yeah, you can get your laser pointer ready. So the above ground storage component is a shallow wetland attenuation feature, which Bob is showing on the screen, that provides, it's about 13,600 acres, and it provides about 46,000 acre feet of above ground storage. The recommended plan also includes a total of 80 ASR wells that are shown as well cluster circles on this map. The red ones are 55 ASR wells total located throughout the watershed. There's, as you can see, they're sited along tributaries that drain to the lake. The plan also includes 25 ASR wells that are co-located with that above ground storage feature, the wetland attenuation feature, and those are shown, as Bob's highlighting, as yellow circles on the map. And of those 80 ASR wells, some of them are located in the upper Floridan aquifer, and then others are located within the Avon Park permeable zone. And in addition to above and below ground storage, the recommended plan also includes about 4,800 acres of wetland restoration, which are shown in green on the map as the Kissimmee River Center wetland and the Paradise Run wetland. Next slide, please. So I think this slide is really useful to show how ASR wells can complement above ground storage in order to improve performance of the project with a much smaller project footprint. So the graph on the right shows two different storage combinations. So the blue line is a smaller wetland attenuation feature facility, which provides about 43,000 acre feet of storage, which is slightly smaller than the storage provided by the recommended plan. This shows the storage with 25 co-located ASR wells, which is the number within the recommended plan. And the orange line shows a much larger reservoir with 200,000 acre feet of storage, but that does not include any co-located ASR wells. So although both of the surface storage features allow for rapid filling during extreme events where lake releases would otherwise be sent to the estuaries, during some of the wettest years, The larger reservoir without ASR wells becomes full and is unable to accept any more water, while the smaller surface reservoir can send water to the ASR wells, which allow that to be filled more than once during a high lake stage event. This is an important consideration when we cite project features, since not every reservoir location is suited for co-located ASR wells. For example, in areas where we have numerous permitted agricultural irrigation wells, it can be difficult to site ASR wells without impacting those existing legal users. So, considering the challenges associated with acquiring large areas of privately owned land for surface storage features, this really shows how advantageous it is to co-locate ASR wells with above ground storage features. Next slide, please. So we added in 3 slides on project benefits. As you recall, the major objectives of the project were related to providing benefits to Lake Okeechobee, the Caloosahatchee and St. Lucie estuaries, water supply benefits, as well as wetland restoration benefits. So this slide shows benefits that the recommended plan provides to Lake Okeechobee. So the recommended plan increases the amount of time that the lake is within the ecologically preferred stage envelope. It decreases the amount of time that the lake is below and above the preferred stage envelope. And it also decreases the percent of time that the lake is below the extreme low stage, which is less than 10 feet NGVD 29. And the storage features within the project also allow faster recovery when high lake stage events do occur by providing both above and below ground storage for floodwaters. So the table on the bottom of the slide shows the effectiveness of the recommended plan, which is based on 3 different lake performance measures: the lake stage envelope, an ecological indicator score, and extreme high and extreme low stage events. So the SERP goal is a lake weighted index score of 0.72. And the future without project condition, which is shown as FWO in the table, just a reminder, that includes projects that were authorized at the time that the modeling was done for the project. And that achieves a lake weighted score of 0.68, or 45% of the SERP goal. So the Lake Okeechobee Watershed Restoration Project recommended plan, when combined with other authorized projects, provides a 9.2% improvement over the pre-SERP baseline, so before any SERP features were constructed. And it provides a 78% achievement of the SERP goal, and that's specifically for Lake Okeechobee. Next slide. So this slide shows the benefits the recommended plan provides to the northern estuaries, the Caloosahatchee and St. Lucie estuaries. So for the Caloosahatchee estuary, the recommended plan reduces flows by an additional 36% compared to the future without condition. And it decreases by 43% the number of months when Lake Okeechobee releases cause the salinity criteria in the estuary not to be met. So for the St. Lucie estuary, the recommended plan reduces flows by an additional 17% over the future without condition, and it decreases by 49% the number of months where Lake Okeechobee releases cause the salinity criteria in the St. Lucie estuary not to be met. So we also did a sensitivity run with the EAA reservoir, which was not authorized at the time of project modeling. So that was actually not included in the future without condition. And when combined with the EAA reservoir that was planned by the district last year, the recommended plan is close to achieving the SERP goal of an 80% reduction in discharge events from Lake Okeechobee to the Caloosahatchee and St. Lucie estuaries. Next slide,
and I
please.
just wanted to interject, Michelle, in case the panel is not aware of it. The Everglades Agricultural Area Reservoir is a reservoir that's south of Lake Okeechobee. So it's another component of the Everglades Restoration Plan, but it's essentially a component that's actually south of the lake. So when both of these projects, the project that we're talking about today is north of the lake. When we couple it on to the operation of the EAA reservoir, the Everglades Agricultural Area Reservoir, both of those project components in tandem talk about is exactly what Michelle talked about with the SERP goal of 80% reduction in discharge events from the lake. So I just wanted to let the panel know about what the EAA reservoir is.
Thank you, Bob. And I should add too that the modeling was done with both the wetland attenuation feature as well as the ASR wells. So these benefits include both project features working together. Mm-hmm. And this last slide shows the benefits to water supply provided by the recommended plan. And so the water supply benefits come as a result of keeping the lake within that ecologically preferred stage envelope. And that is actually above the water supply cutback trigger levels. So the benefit of including ASR in the plan is that ASR wells can be recharged during periods where lake levels are high, and then water can then be recovered during dry periods. So the table on this slide shows water restrictions for the Lake Okeechobee service area during the 41-year modeling period of record, which was 1965 to 2005. And the recommended plan reduces water supply cutback volumes to Lake Okeechobee users by 24% compared to the future without project condition. So that was the last slide I have on the project benefits. I don't know if Bob, if you want to take any questions before we move on to the ASR well component of the project.
Certainly, we're open to panel questions about that. The only other thing I wanted to mention is that all of the numbers, all of the metrics that Michelle just talked about are really outputs of all sorts of various models that we use to evaluate project benefits. And we call these things, just globally, we call them performance measures of the projects. And all of this analysis is included in the project implementation report, which is it currently available to the public, Michelle, as it stands right now? Is a draft version of it available?
Tim, I'm going to ask you, is that still posted on the Corps' website, the revised draft PIR-EIS?
Yeah, the last time I checked, it was still on there last week, so it should still be available for everyone to be able to download.
Okay, thank you.
Yep. So that means that if you do really want to dig in and take a look at this plan and all of the performance measures that were evaluated in the process of selecting this plan, I encourage you, if in the event that you want to read another 1,000-page document, to go to the website, and we can perhaps provide it again as a follow-up to this meeting to the panel if you'd like to actually see what that report looks like. And it's a combined project implementation report and environmental impact statement. And where is that document actually in the process of approval right now? Tim, can you let us know where we stand on the actual full approval in the Corps' chain?
Sure, Bob, no problem. So we submitted the final PIR EIS back in December to our headquarters review team, and we've been working with them over the last, 7 months now, addressing comments and getting that ready for the final state and agency and public review. We are currently awaiting concurrence to release the final report as well as the chief's report for review, but we're anticipating that should be out for everyone to review within the next month or so.
Okay, great. Thanks, Tim. So with that, would any questions or comments from the panel about that? and about the analysis that Michelle just shared?
This is Sam. Thank you, Michelle and Bob. That's exactly what I was hoping to see. And I really do appreciate it. And if it's possible, if you could provide us a link to get to the report, that would, not something I want to read for entertainment, but I sure would like to get a quick look at it. Again, thank you.
Absolutely. Yeah, we can provide the link to the report and section 6 of the report, which provides details on the benefits of the recommended plan, would be particularly useful. So we can provide that link after the meeting.
So my comments are related to, it looks like this analysis is just about water volume and water flows. Has there been an analysis done on benefit about nutrient reduction between the different projects?
So water quality improvement is actually not an objective of the project. The project objectives really relate to water storage, reducing discharges to the estuaries, improvements to water supply, improvements to lake ecology, and increases in wetland acreage within the watershed. So water quality is not an objective. There is some information. We do anticipate some ancillary benefits to be provided to water quality, and that information is provided within the project implementation report, but it is not a metric that we evaluated in order to make a selection of the recommended plan.
Any other questions or comments? Renee, did you want to follow up to that question or response?
Well, I guess I'm just curious as to why. That was not part of one of the goals.
So, Bob, I'm not sure if you're able to access the slide from yesterday where the history of the project was discussed, but in the previous planning effort of the project, planning was halted on the project due to water quality cost share guidance that came from the Assistant Secretary of the Army, and that related to cost sharing of project features related to water quality. So as a result of that decision, it was determined that when planning began again for the project, that water quality would not be included as a project objective. And Tim, you may be able to elaborate that on a little bit more from the course perspective.
Sure. I think you captured the essence of the reasoning there, Michelle. But yeah, we received direction from the Assistant Secretary of the Army back in 2005, I believe, maybe 2007, that the Corps as a federal entity would not be cost sharing in water quality improvement features that would fall on the responsibility of the state. So it was determined that there's not a federal authority to do that at that time. It doesn't mean we don't support it, but that was a state function. So we're leaving that to the state to address through their programs.
Okay, thank you for the
As Michelle said,
clarification.
there is, sure. But as Michelle said, there definitely is an ancillary benefit to water quality anytime that you improve wetlands or create shallow storage features above ground, as well as through the ASR systems.
Okay. So moving forward, as as we discussed today, is all about looking forward to the future program of ASR implementation that we've got coming up. And with that, I wanted to pass the mic to Jennifer Gent, who's the project manager for the engineering components of the project. So Jennifer, are you there?
I am. Good morning, everybody. I'm excited to kind of go through all of this. So with the Lake Okeechobee Watershed Restoration Project Accelerated ASR Well Program, move on to the next slide. Like Michelle was talking with you guys yesterday, the state appropriations, we received $50 million in fiscal year 1920, and we're expecting another $50 million for this fiscal year 2021. So with that funding, we had to kind of come up with the incremental phased approach to implement the program, and the specific watershed ASR projects prioritized for the state appropriations. You know, the first 50 million, there was no guarantee there'd be any more. So we needed to figure out where were our prioritized locations. And so this is kind of where we're going to be focusing our funding for a little while. So move on to the next slide, Bob, please. We wanted to focus on definitely on the C38. C38 canal is the locations A and B. Bob can point them out. A includes the pilot project, the Kissimmee River ASR pilot project that Bob and June went over yesterday. So we have a pretty good understanding of what the geological and hydrogeological assessments are over there. We also wanted to go up into Paradise Run to try to maximize the capturing. And so these are locations, and they could be 4 to 10 ASR wells per well field, and there'll be a variation. We're looking at the upper UFA and the upper Florida and aquifer, and some in the APPZ. So we went ahead and decided we wanted to go with that. Now, the second area that we kind of focused on were the S191 basin clusters, and this was a good area because L63N, one of the ASR projects that Bob kind of went over with you yesterday, is in the APPZ area. That was the one that was operated in the 80s. And we just recently, this year, finished a mechanical assessment on the well and found that it still works and it's promising. And so with the information we had there, we'd like to expand ourselves and go down the L63 canal. So it goes through the L63N is C. And then on D is located right on the C59. And this is where the S191 structure is. So the S191 structure would allow us to pull water from the lake and put it into the L63 canal to achieve these. So Bob made, they're all on the tributaries, and they're focusing on pulling the water from the lake at this point. So, and then E is located in the L63 South. So we went ahead and we started phase 1, which was a site evaluation hydrogeological assessment of the areas. And it became apparent that we had a lot more information on A and B than we did C, D, and E. So A and B are the C38 clusters, I'm going to call them, and C, D, and E, we're going to call the S191 clusters. So we did conceptual site plans of a well field layout and how the sequencing of those plans would be. And we tried to approach them in a very stepwise approach. At the same time, we went ahead and started doing assessments and repairs on the ASR wells that we have existing there to try to get them up and running, knowing that having those up and running when we do the exploratory wells out here would help us see a lot more influence, if there is an influence, between the different layers and how these would operate together. Hopefully furthering an opportunity for the science that we need to go forward and keep reviewing. At the same time, we've also started a new evaluation because Bob talked about the treatment evaluations, treatment technology evaluations that were conducted, but that was probably about 10 years ago, and stuff has kind of moved forward. Technology has moved forward. So we're back to doing another treatment technology evaluation. And we'll talk a little bit more about that later. Bob, can you move on?
Mm-hmm.
Awesome. So I keep saying a stepwise approach. So this is kind of how we approached each of the locations. So we looked at the phase one, and we started with phase one, which was the conceptual hydrogeological evaluation. That was what we were talking about earlier with like the conceptual site plan of layout of a well field and the sequencing of how we would get one up. If we had enough information at this point, we would move on and we wouldn't necessarily have to do that next phase, that next item on there, which is the geotechnical drilling of those 2,000-foot cores. In some locations, we do have that information like Paradise Run. So there's not necessarily a reason to go to that point. But for the S191 basins, they were not, we don't have enough information down there. So that's where we're going next. So we are currently have a bid out and are looking and evaluating it to do the geotechnical drillings of those 2,000-foot cores in the S191 basins. So hypothetically, or best case scenario, we're hoping to start in the beginning of this fiscal year, this coming fiscal year, which would be this October, to further our knowledge. Now, with those geotechnical corings, there's a large opportunity for science and evaluation. And what else do we need to be looking for? And so that's where I kind of want to pull your attention to as we're going through this stepwise approach, is where you guys in your wisdom on, because like I said, I've been drinking from a fire hose for about a year to understand ASR, and you guys have been doing it your whole lives, where you would suggest we put and what types of science and evaluations we put in different places. So moving on to the next phase. So if we don't need to do the geotechnical drilling of the 2,000-foot core, we'd move on just directly to the geotechnical drilling of the UFA and the APPZ exploratory wells. This is where we're going with C38 North and C38 South, the ones that are adjacent to the existing Kissimmee River ASR system. At the same time, we're also trying to get the Kissimmee River ASR pilot project up and running so that when we do the exploratory wells, after we evaluate them to see what their capacity is so that we can size our equipment and decide where we need to move on and maybe how many we could fit and what the spacing would be. It would be ideal. I think it would be an ideal opportunity to have the existing Kissimmee River ASR up and running, and we can see the influences between the two as we are operating that and what it does to these areas. So the UFA and the APP's exploratory wells will not have the equipment on them because we need to understand it. So that's like it's a stepwise approach. So so while we're doing that, we're also looking at the biological evaluation, looking at the banks, where can we impact the least amount of ecological, the mangroves, the tortoise, all of that kind of stuff. We're also doing the treatment technology evaluation for the recharge and the recovery. So what do we need to, how do we need to treat the water to put it in, and what do we need in order to pull it out and be able to put it right into the lake? And we're kind of continuing on with wildlife relocations. One of our sites, L63N, the existing APPZ well, there's 109 gopher tortoise holes. So that's a fun little extra contract that we have running in there. So once we do these exploratory wells and we determine what their capacity is, we're hoping that the treatment technology evaluation kind of coincides, and we're going to be able to move on to phase 2 design, which would be the construction of the ASR systems, including the treatments, the filters, the pumps, and we're looking at doing it in a modular approach, knowing that the way funding is, we may be able to get 2 wells, 4 wells, 6 wells, but we want to be able to develop these in such a way that they can be expanded if the science underneath it says that it can handle an expansion in the system. So once we get those first 2 on C38 North and C38 South, so we'll have 1 APPZ, 1 UFA, ASR wells with the treatment in the facilities, and we'll be able to operate, and we'll bring them into cycle testing at the same time that we're bringing in the C38 South well pair into cycle testing. And we should have the existing Kissimmee River ASR working around the same time. I think this creates another unique opportunity for us to continue the science. And so I kind of want to point you guys to that again and what you think we would be doing during that time, and what information can we achieve in that point. Once we operate and cycle test those things, we'll be able to adjust the well field to make sure that our spacing is correct. And so we'll be able to, at that point, expand that well pair couple in C38 North right now and C38 South, the ones we're moving forward with, into a well field. If with unlimited monies, we could go straight to whatever the science told us we could fit. But at this point in time, the money's kind of phased. So we're kind of taking a phased approach. But I think this is where we could take off, is right in that last adjust the phase 2, and we could construct another ASR well couple. We could construct the other 8 depending on what it can handle, and then we go back into cycle testing. All right, Bob, move on. I'm sorry I talked a little bit long on that one. So what is complete and ongoing? I told you about we are currently working forward on C38 South and North to do those large exploratory wells, the 24-inch ones. And we currently have our UIC permit applications into DEP. On the S191 basin clusters, as I mentioned earlier, we're getting ready to embark upon the Florida Aquifer System Exploratory Coring and Monitoring Well Program. We are continuing our assessments and our repairs to the Kissimmee pilot ASR. And we are working with USGS to continue the research to move forward into the next step of the nutrient reduction, microbial inactivation, and the plugging potential evaluations. Next slide, Bob. Thank you. And the L63N, as I mentioned earlier, earlier this year, we went ahead and we did a mechanical assessment on it, and it is alive. It's capable of pumping about 7 million gallons per day, which gives us a great opportunity as we're developing up the S191 basins to have already an ASR well there. So strategically, this well is very important. It currently operates under an aquifer exemption. So this well is one of those wells that we can really evaluate the biological and the nutrient uptake in without necessarily having to treat. And so we're working on this one, moving it forward, and I'll explain this one in the next slide. Go ahead, Bob, if you can move on to the next one. We're working with this project, this is kind of like the short-term program of how we're spending the funds right now. And as we're going through it, you'll see there's some that say to be determined, and that's because that's second increment of 50 million we're just finding out about, and we haven't really fleshed out exactly how far it would go. Plus, we need to get our science program put into this. We need to make sure we have enough funding to keep moving along to answer all of those questions that Bob went through yesterday with you guys. So on this well, we see ourselves getting it up and running under the existing permits and exemptions while we're going ahead and finishing up the decision on the treatment technology so that we can use the same type of treatment technology out here. And then we'll go back and evaluate this site. We're doing a coring out here to see if it could handle another well and fully develop it. So this L63N ASR, we're hitting this one in a phased approach. We're going to try to get, like I said, get it up and running, have that going while we're installing all the treatment technology stuff. Once we have all of our treatment technology in place, we'll be able to adjust our exemptions based upon the treatment chosen. And then we'll be able to also decide whether or not it could handle another well and where that well could be. And so we could double up that treatment. So this is a really neat opportunity in this site. The next project on our short-term funding is the Kissimmee River ASR. And we're currently getting this one up and running under its existing permits. And we're hoping that after we do that, because the operating system on it is pretty old, we're going to have to update it. But we want to get it up and going so that we could start some science on it and and have it going while we're designing it to be up the next phase. Now, the next phase could also include an additional well or some kind of expansion to the existing facilities to be able to contain another well. So we're looking at both of these sites as expansion areas going forward, but right now our short terms get it up and running and get our science moving. The next two projects are the ones that are kind of the most exciting for me, which is the C38 North and South clusters. I was telling you we're doing about the exploratory wells. And in like a perfect world, if you go down a little bit in that October 2022 is where we think that we would be cycle testing. So that would be the first time that we'd be able to start looking at how the locations compare, if they have any impact on each other due to their vicinity to themselves, each other, or to the Kissimmee ASR. So that's a date to be looking forward to. And then, as I said before, what's coming most recently will be what's coming the soonest will be the S191 basin locations exploratory coring and monitoring well program. I know this is a lot, but this is kind of where we're going. And like I said, it's very incremental. I see lots of opportunities for some really cool findings and interesting progression. And I can't wait to have the conversation of what you guys see and when. So Bob, can you move to the next slide for me? So this is the C38 South cluster. And Bob, can you point to where the existing Kissimmee River ASR is? So that's where our existing Kissimmee River ASR is. And you can see how we have laid out the well field for C38 South on the west side of the C38. We are currently permitting C38 South-5, those two wells which are closest to State Road 78. Those are the ones that we have our current permits in over at DEP to go ahead and do the exploratory wells. Along with those exploratory wells, we'll be also installing some monitoring wells, dual zone monitoring wells. And you can see all of those in red. I guess skip to the next, unless I missed something you want to point out. So this is the C38 North. And this is where you guys have been looking a lot. And there was a lot of questions yesterday regarding the wetland area that were the Paradise Run wetland area. And so here in this is interesting. You can kind of see the original channel. And when they said they were going to be digging in and we're going to try to reestablish that channel going south. Okay, and up there is where the pump station will be. They'll pull the water from there and put it into that wetland attenuation area. Now you can see where our well field's set up. It's kind of in a really neat location, but we're not progressing yet with the wetland feature. So our thoughts is to make sure that we have the tees set up on our well field so that at some point there is a possibility for us to be able to reassert some of the aquifer water into that wetland. We'll be able to, but that isn't in the current plan. We're just going to set ourselves up now so that it can be possible one day, if so deemed appropriate. So in this one, we're developing C38 North-3. Those are going to be our exploratory wells. And we wanted those ones to be there because it allows us to go ahead and use the existing channel that comes into the bank to pull water and to release some of the water as we pull it in and out so that we do less damage to the flora and fauna along the bank. I think I'm probably going to hand it over to Bob with this next slide. Skip it and let's see. Yep, here's Bob. Thanks, guys, for the opportunity.
All right. Well, what Jennifer just told you is that these are the two locations, the C38 North, which is right across from the Kissimmee ASR project, and that's the C38 South site, and then the C38 North site is up at Paradise Run. We at both locations we already have done an awful lot of hydrogeologic evaluation from the Kissimmee ASR system. We sort of know what to expect there, and at the Paradise Run location at C38 North, we've already got a dual zone monitor well from the original exploratory well that we did as part of the LOWRP program. So armed with that initial information, we've submitted permit applications to the DEP to build the first exploratory wells, which Jennifer was talking about. Now, the exploratory wells are going to be designed as large diameter, 24-inch diameter wells. The idea being that we're permitting them as exploratory wells because we will be doing an exploratory program, but with the intention of, if these wells are successful, if they have the capacity to be able to be pumped at 5 million gallons a day, we're going to re-permit the wells as ASR wells. So what I'm sharing with you here is a schematic, one of the schematics that we've filed with the DEP as part of the permit applications. For the exploratory well, this would be what the exploratory well looks like in the upper part of the Floridan aquifer. We're anticipating using a 24-inch diameter casing down to roughly 900 feet or so, and then, or actually somewhere 600 feet with maybe 200 feet or so of open borehole in the upper part of the Floridan aquifer. And the Avon Park permeable zone well, a little bit deeper, would be somewhere near 1,200 to 1,400 feet below land surface, but it would have a same essential construction type schematic. And then we've also submitted permit applications for monitoring wells. This is an example of what the Avon Park permeable zone monitoring well would be, probably a 6-inch diameter type well there. And then this would be a surficial aquifer monitor well, something completed near the base of the surficial aquifer, so that we can monitor the effects of the overlying aquifer units above the Hawthorne group. So anyway, this is just a schematic of all the permit, what supported the permit applications. The permit applications for the wells have been in at the DEP for a couple of months now, so we're anticipating hopefully getting those permits, draft versions of the permits shortly. And once we move through the permitting process, we're hopeful that we could actually be building these wells, these exploratory wells, the first well pairs and clusters of pairs, maybe by next year sometime. So yeah. So these are about those systems, the C38 South and C38 North. We do want to move forward with exploratory wells. We are developing the construction plans and testing specifications so that once we get the permit for the wells to be able to get from the DEP, then we can procure a drilling contract to actually get a well driller on board to be able to drill those wells. And certainly as we're drilling those exploratory wells, we anticipate doing water quality differentiation between both the upper Floridan and the deeper Avon Park permeable zone. Once we build the wells, and these are going to be, just so you understand, when we talk about a well pair, what we're actually talking about is one ASR well completed in the upper part of the Floridan, and one completely different, distinct ASR well completed in the Avon Park permeable zone formation. And those wells will be kind of close to each other, maybe 50 or 100 feet apart from each other, and that will be one pair of ASR wells. And those wells are going to be relatively close to each other, and when we construct those wells, we will also be building the dual zone monitor wells at various distances away from the ASR pairs And we'll be trying to do evaluations like we spoke about yesterday, taking a look at analysis for aquifer anisotropy, to take a look at the influence, the hydraulic influence of the wells themselves, so we can maybe get some idea about what kind of buffer zone we would want to create within the aquifer. And again, we'd want to do some kind of modeling to figure out what kind of recovery efficiencies we might anticipate from the wells. And the other aspect, hydraulically, is if we intend to do two ASR wells, kind of close to each other, stacking different vertical horizons within the aquifer, we want to understand how those wells interfere with each other. So that is what we will be looking at when we do the testing and when we build those that first pair of exploratory ASR wells. So those are the wells that are along the C38 canal. This is the cluster of sites that we have along this S191 basin. And of course, we heard a little bit already today and yesterday about the existing ASR well at the L63N, which is completed in the Avon Park permeable zone. Very high capacity well. But what we want to do there is, at each one of these sites, is construct a continuous core where we're moving through a contract right now where there is a firm that is capable of building continuous cores, extracting complete intact cores down to a depth of about 2,000 feet below ground, which will enable us to really do a very detailed hydrogeologic evaluation of the potential of each of these cluster locations. So that is the first step at each of these sites, is for us to go out and drill a continuous core, which is going to provide us with a whole bunch of rock. So with regard to this continuous, we're going to call it, or you're going to start to hear me refer to it as a continuous coring project. And of course, it will provide specific hydrogeologic and geologic information about the properties of the Floridan aquifer system. We're looking at a contract of contracting to have them done at 4 locations, and obviously incredibly detailed information about the lithologic aspects and the water-bearing properties of the various strata within the Floridan aquifer. And after we construct the continuous core all the way down to 2,000 feet, we're going to then bore out the boring of the well itself and complete them as monitoring wells. That'll either be constructed in the upper part of the Floridan aquifer or the Avon Park permeable zone. And so we're already going to be able to get an awful lot of data, monitoring data, that we'll be able to integrate into more detailed groundwater models. When we talk about how these sites are going to interact with each other, right? I mean, we're envisioning having well clusters at each of those locations, right? How many wells we're going to be able to construct here, however many wells we're going to be able to add to a cluster or well field here, and perhaps another well field at this location. What we need to be able to do is integrate all of that data from these continuous cores into a groundwater model that'll actually help us design how large those clusters of wells can be. So a little bit more about this program of being able to extract literally what could be 1,500 feet of rock from the top of the Floridan aquifer down to 2,000 feet. We're going to have a wonderful opportunity to look at the petrography and mineralogy of the rock that comprises the storage zones and the confining zones. We'll be able to do more of those geotechnical tests, right, like the fracturing analysis, and we'll be able to analyze rock strength of the intervals within and overlying and underlying the storage zones. We're going to be able to give some of these cores to the USGS, to John Lyle. You heard yesterday that he is already devising a series of column experiments where we'll be able to put these cores into columns and pass water through them to analyze whatever water quality improvements might take place, phosphorus reduction, nutrient microbial activity, and the potential for plugging if the biomass of those biofilms that John talked about yesterday, if they're going to actually create problems down the road, or will re-release nutrients within the sediments. So we're really looking forward to being able to do some interesting stuff with the column studies with regard to plugging and microbial processes within the rock. And then I mentioned yesterday that the USGS had done some sequence stratigraphy, right, looking at upward and downward regressive and transgressive sequences of what was taking place in the actual during the sea level 40 million years ago. Sea level rises and falls, upward and downward fining sequences, coarsening sequences. We're really going to be able to get a glimpse into how the Florida platform was forming during the Eocene period. So we're going to have great opportunity to look at that rock and do that. And as I mentioned, looking at microbial activity also. So as you can tell, I'm a little bit excited about that program. So the other thing that we have in motion is trying to figure out what the latest advances in treatment technologies are, right? We know how the treatment process worked at the Kissimmee ASR system. You know, June did a wonderful presentation yesterday about how the Kissimmee ASR system is operated. The choices that we made back then about a media filter coupled with UV, you know, those choices were made 15 years ago. So in the world of water treatment processes, there's 15 years worth of evolution and improvement in all sorts of different technologies. Screening, media filtration, ultraviolet disinfection has actually improved. The vendors and the technologies have all evolved over a 15-year period. So what we did is we enlisted the help of Stantec to take a look at the universe of treatment processes that are available now in the marketplace, to try and help us make a decision about what kind of processes ought we look at now as we envision building these first couple of well pairs and new systems. We want to make ourselves aware of what choices we can make in the near future about treating the surface water to meet standards when we put it into the aquifers. So what they've done is went out and gave us a whole bunch of different choices and coupled them up with each other. And this is a schematic of a report that Stantec has just recently prepared for us, and we're certainly happy to share this if you're interested to know about water treatment processes. What this sort of shows is there's on the left-hand side of the screen, this would be an intake screen that would be adjacent or installed within the canal or within the lake, and it would be pulled through that screen by using a raw water pump, and the water would actually go through a coagulation process. This is an alternative. This is one of the alternatives that Stantec has proposed for us. and it would involve a coagulation process where there would be a chemical additive that would drop out some of the particulates in the water. That would then, after the water went through a coagulation process, it would pass through an ultrafiltration membrane that would be very highly efficient to be able to pump the water into the ASR wells. And there would be some aspect of residuals that would either come out of the screening process or the coagulation process that we would have to deal with some sort of a residuals management. We would expect that would be necessary. So a little bit more about this treatment technology. Is that within the report, what they've done is actually a very useful costing analysis where we looked at 5 different treatment trains and what the capital costs would be for, I think this would be for a hypothetical 10-well ASR system for a treatment train to feed 10 ASR wells, which would be a 50 MGD plant. And ultimately, what we looked at the costs over a 50-year life cycle, and some of the front runners that have actually come out are this alternative coagulation and ultrafiltration process is the purple line, which is actually quite an efficient process that would almost meet all primary and secondary drinking water standards. That looks like it's a front runner for that's coming out from this process, this evaluation, and also the blue line amongst these 2 top competitors is the media filtration coupled with ultraviolet filtration, which in essence is what we've done at the Kissimmee ASR system. And we know that what we did at the Kissimmee ASR system did not meet the coliform standard. For instance, that's some of the stuff that June shared yesterday. And really, it's interesting because the cost differential between a media filter and coupled with UV and a ultrafiltration process coupled with coagulation, they're actually very similar. And so we're intrigued by these results, and what we're doing is the report is currently under evaluation by the Corps and the Water Management District, and once we use this document as a decision document to actually move forward, what we're likely going to do is take a look at what those 2 technologies are in terms of the latest and greatest that are available on the marketplace, and maybe do a test where we invite some vendors to come out to Lake Okeechobee and hook up their pilot processes of using these 2 technologies, and to really do a head-to-head comparison of which units work best. And then by going through that evaluation, we might ultimately make a selection for the treatment process to install on the ASR wells that we begin building. Okay, so that is the essence of what we're moving forward with right now. We're moving forward with on many fronts. We're in the process of trying to evaluate the L63N canal and get a system and get that up and running. Looking at reoperating the Kissimmee ASR system. Looking at constructing test wells and exploratory well pairs at the C38 North and C38 South, and then getting continuous cores constructed at sites that we don't know all that much about, and a lot of these things are going to be coming at us really within the next year or 2. So with that, Would the panel be interested in discussing a little bit or having questions about our near-term plans for the things that we just spoke about?
Bob, this is Sam. On the figure that we're looking at, are those annual costs or is that cumulative?
I believe that is cumulative, Sam. And that includes capital costs and O&M. Actually, it includes everything, soup to nuts, capital costs, and then all of the things that would be required for actually operating those facilities. Maintenance, electricity, chemicals, essentially all of the costs were included in those projections.
Bob, this is Tom Missimer. Just a suggestion. You may want to look at one more process, which would be dissolved air flotation plus UF, because the material is so fine in that water. If you use the coagulant with DAF and UF, you won't have to use sand filtration as well. The thing is, if you aggregate, for example, if you have 10 ASR wells, when you operate plants like this, the larger they are, there's a reduced cost. So if you operated a single plant to pre-treat the water for 10 ASR wells and then piped it to the wells, you would probably have a lower operating cost. So it's something to consider.
Thanks, Tom. Yeah, and that's a good point. This projection is essentially based on the idea that one treatment plant would be built to feed 10 ASR wells, which would be 50 million gallons a day. Which, by the way, 50 million gallons a day is about what the city of Fort Lauderdale uses. It's a big plant, and this evaluation essentially, and we needed to make some basic assumptions. At least this is a very first level cut of the evaluation of the treatment trains. But this evaluation is essentially based on if one large water treatment plant was built to feed 10 wells. Now, what we would want to do is when we actually go out and have the vendors show us what their treatment trains look like, it may be more efficient or economical to not build one large water treatment plant, but to have wellhead mounted systems actually on the wellheads themselves. And we'll need to go through that process. That's another step down the road of actually doing a more detailed design of what is the best way to facilitate these treatment trains.
I have a question. Are any of these treatment options planned to be used at the back end, specifically drawing water out of the wells during the recovery phase? And are there any treatment options that could be done at that end to potentially remove the arsenic if it's coming out of the well?
Well, I actually do believe that I think the ultrafiltration process, if we actually wanted to go with the ultrafiltration or microfiltration process, I do believe those are capable of removing metals. Although, Renee, I would have to say that at this point, our assumption is that we would not be anticipating doing any additional treatment on the recovery side, other than aerating the water, because we're sort of expecting that the arsenic is going to be a very temporal phenomenon. But we will look at the ability to retreat the water through the process when we're recovering. We know that we have to aerate the water, for instance, because when we are recovering the water from the ASR wells, the water itself does not have any oxygen in it. The aquifer itself is anaerobic, and after storing the water for weeks or months on end, when we recover the water, we do know that we have to aerate the water, which we've done at the Kissimmee ASR site with the Cascade aerator. That the technology to be able to re-aerate the water is not really all that difficult. But that's where we are with the treatment process right now.
Hey, Bob, just a quick comment on Renee's question. Drinking water plants typically remove a lot of the metals through, I believe, granular activated carbon after they, as one of the filtration and reactor steps. So that's, like Bob said, that's not really going to be an issue. We're not having the post-recovery treatment. Either that, the other option is to blend waters, and dilution will reduce the concentration of arsenic. But the reality is the Surface Water Clean Water Act criterion for arsenic, even in Class 1 recreational waters, is 50 micrograms per liter. So we have a lot more leeway, we can easily meet that criterion nearly all the time based on what we've seen at Kissimmee. It's the arsenic in the aquifer under the Safe Drinking Water Act that's the hang up.
This is Tom Mismer. I just have one question. When you do get arsenic discharge from the wellhead, what's the predominant valence? Is it +3 or +5?
It would be +3. The more reduced, because the aquifer is so, it's sulfate reducing, so everything is going to go down to a lower valence state.
Because +3 is more toxic than +5. That's the reason I asked.
Yeah, I believe I have a very small data set for arsenic speciation during cycle 1, but even there are enough things to reduce the AS +5 to AS +3 in the aquifer. But the recovered water that came out of the ASR well during 4 cycles was, with the exception of 2 or 3 samples over 4 years, it was always below 10. It's a transient issue in the storage zone only.
Any more questions, conversation from the panel? All right. Well, that actually is the end of the actual technical discussion that we were going to share with the panel, in terms of, we wanted to let you know what we've got coming up over the next year or so. And building test wells, getting continuous cores, moving forward with the treatment evaluation process. And we certainly are happy to have whatever recommendations that the panel has regarding the science that we can do while we're implementing this program over the next year, obviously, to be smarter about how we go about this testing program, and to be able to pull as much information as we can out of the cores and the wells that we are getting ready to construct. I'm actually going to jump for a minute to the very last slide that I had for today. And I wanted to kind of put in a context of when the panel begins to formulate its recommendations for us. I wanted to just share some thoughts that I had about sources of data that we can use to support the science plan and the recommendations that you give us. And just a few ideas here to get your mind thinking. Certainly, we have got, as I hope you've surmised, we've already got a huge quantity of data that is already available that we've analyzed, but certainly could reanalyze again to respond to some of the questions and uncertainties. Additionally, of course, we're very open to whatever experiments might be available when we get the Kissimmee ASR system up and running, hopefully next year. And the L63N canal, now that we've evaluated that well is alive and can be operated, we look within maybe the next year or two to be able to get that ASR well up and running again. So hopefully we'll have some operational ASR systems that we can play some games at and actually do some evaluations to respond to some of the scientific questions. Of course, we could take a look at some of the other operating ASR systems that are out there. We just don't need to focus on the systems that we're building, but there is an awful lot of ASR facilities that are operating in South Florida. If there's any way that we can ask for analysis of some of the data that's already available from other ASR systems, that may be available to us. Certainly these continuous cores that we're going to be collecting over the next year are going to be really a treasure trove of information. And then when we get the UIC permits and build the test wells and exploratory wells at the two C38 clusters across from the Kissimmee ASR system and at Paradise Run, whatever evaluations you think we ought to consider while we're building and testing the first well pairs and the monitoring wells that we build around each of those well pairs, that's going to be another source of information that we can integrate in whatever your recommendations might be. So just wanted to offer those 5 sources of data that may be able to be used for the science plan as we move forward. Okay. Comments, questions about that?
Yeah, Bob, as I look at this slide, it feeds into something that's been on my mind the past couple of days. We're on the brink of big data here in terms of all of the data being collected for all of the CERP programs, not just ASR. Maybe you're already there. I don't know. But it's a massive amount of information, and even today, just peeling back the layers of the onion of the different components of projects, the science questions being asked and answered, and the different scales. Are you zoomed in? Are you regional? What questions might we want to ask of all ASR systems moving forward, as opposed to the questions that we ask of a single ASR system at a specific location? Those might be different questions. And also in terms of the temporal scale, the frequency of sampling, and then my head really explodes when I start thinking about detection limits and efficiencies in sampling. So if you have ecological sampling going on for water, and you have all of this water sampling going on for ASR as well, how is that coupled? Is it, are there efficiencies and somehow coordinating that? And also the, I guess going back to the landscape or the horizon view of ASR, if we wanted to plot, for example, or assess the relationship between recovery efficiency and arsenic, or, that may be a bad example, but are we, is everything being set up today to foster these bigger picture horizon type questions, or is it still rather isolated right now?
John, you always ask the tough questions.
Sorry.
I think where we are right now is we're kind of looking at our navel. We're just going on an incremental basis of trying to construct wells and soaking out as much information as we can from the wells themselves that we built, either through the cores or the first pairs of wells. I mean, the way I see it is that we do have several different scales of questions to be answered as this unfolds. You can look at one well pair, and that will be one level of data. And then when you start to think about clusters of wells and how one well cluster might influence another well cluster, you're going to have, some sort of like a sub-regional look or evaluation. And then when you actually construct a model to anticipate what could be the 80 ASR wells at a dozen different cluster locations sprinkled throughout the map that you've already seen, what will be the impact of those 80 ASR wells on each other? We just don't know an awful lot when you actually scale up the entirety of the program. So, I think for the near term, I think we're going to get some very, very detailed local information about each of the circles on the map that you've seen right now, C38 north and south. We might be able to scale up to a sub-regional evaluation once we start looking at and completing the continuous cores and the exploratory wells. But that's not going to be, the other thing that we really have to consider is that we're already looking like 5 years down the road, 3 to 5 years down the road, of actually having the first couple of well pairs constructed and actually conducting cycle tests on the wells and getting a lot of recovered water data to be able to evaluate the ecological effects. So, we kind of have to take a deep breath and certainly be aware of the larger, longer scale, full-scale implementation of ASR. But we're really kind of just at the beginning of this whole thing. So I appreciate that thought. There's no question that it's out there, but how we frame the answers to each of those different scales, local, sub-regional, and regional, it gets awful heavy real fast.
Right, and then how to manage all of that data so that it's, you don't want to get 5 years down the road and wish you'd done something simple today to, facilitate answering a bigger question. And there's tremendous potential in being able to do this across all of the systems, just from a geochemical standpoint, plotting one parameter versus another, and you might find that, well, when there's not a pattern there, you don't expect a problem, but when there is, you do, and just all sorts of ways that can inform and turn into early characterizations of a site where you really don't need to know more than a fundamental question or two about it in terms of its relationship to cost. To put that another way, the more the more information we have that can be distilled and be informative. Right now we're still, the project is still cutting its teeth on individual sites, and the number of wells is a lot. And at some point this will get easy, and we want to help that point come sooner than later.
Mm-hmm. Well, we're certainly open to whatever thoughts the panel might have on how to get good information, good early information, and then projecting out as we really organically build these well fields and these well clusters, what additional information can be sort of assimilated into our knowledge, so that we do grow these systems intelligently. I really appreciate that perspective, John.
Excuse me. This is Sam Upchurch. Bob, you've really opened the Pandora's box in terms of asking us to suggest ideas and approaches or data manipulation issues and things like that. But are there any specific needs that the district needs from this panel? Are there specific things that you'd like for us to address?
Well, Sam, my expectations are kind of low. Really, the only response that I know that we've really burdened you with a huge amount of information over the last day and a half, and really remember that what I want to have here is this, as a function of this kickoff workshop meeting, is for the panel members to each go back and give us your thoughts on whatever comes to your minds about things that we ought to look at, or interesting aspects that could help us address some of those uncertainties from the National Academy. But then remember, what I'd like to do here, and what's in our scope of work, is that after the panel prepares its thoughts and recommendations as a result of today and reviewing the documents that we've shared, is that you're going to deliver us a sort of report or memorandum of maybe a series of recommendations, perhaps short-term, perhaps long-term, and then we're going to meet again, right? Our scope of work calls for us to take your recommendations, whatever they may be, and we will prepare a response to it, and we will try to develop a game plan of integrating your thoughts and questions and comments over the near term, and then we'll meet again and let's talk about what your recommendations are, and then we're going to go to work. At least South Florida Water Management District, in partnership with the Army Corps, we got a lot of work coming up in the next year. We're going to be constructing these continuous cores. We will be building these test wells and exploratory wells. So what I'd like to do is let us go to work for the next year, and then meet again maybe a year from now in July, and reconvene the panel and give us a chance to tell you what we found, what we've done over the last year. Talk about what the continuous cores told us. Talk about what the exploratory wells, what we found in the exploratory wells, And I look upon this as this is not a one-time deal. This panel, at least in my view, is an ongoing review. I really truly value having this be an iterative process as we move forward. So whatever thoughts have occurred to you in the last day and a half, please share them with us. We will do our best to integrate your suggestions over the next year, and then we will keep meeting, maybe on an annual basis, as we roll this project forward. So that's kind of how I see this playing out.
Well, thank you, Bob. That's helpful. And I like the approach, and it helps us frame our approach, of course, but having a sounding board of technical and scientific folks and is important. And I think, just based on the feedback I received last night and compiled, it was really not multiple pages of meeting notes as much as recommendations and looking ahead and just questions and comments. So I think as we continue to distill in our minds what we've heard, plus what we've read, plus what we will read, and our past experiences, I think we can come up with some recommendations that will really be fruitful.
Great.
So
yeah.
On the agenda, there's a panel discussion. Are we kind of there?
Yeah, I think we're there. We're getting close. I also wanted to change gears just a little bit here, and share with you some of the other comments. Yesterday, I presented a summary of what were the National Academy recommendations about continuing to try to address the uncertainties about ASR. But this is another little change up here. And what I'm sharing here is that during February of this year, we had a RAC meeting where Jennifer Leeds and myself presented the ASR program. And I think we shared the link to that presentation and subsequent conversation and questions. And what I actually wanted to share with you were the comments during that RAC meeting. And this is a slightly different sort of series of comments and questions that we got from the RAC meeting, and I think there's value there. And first off, I wanted to recognize that when the public makes comment during RAC meetings, we take them down, and we do want to address them seriously. So I wanted to convey these are thoughts that the public has, not exactly the National Academy of Sciences, but these are general questions and comments that come from the public. And I want the panel to be aware that while we continue to address all those uncertainties that remain, we also want to be cognizant of what the public thinks. And I do want to be able to address these as we move forward with the ASR program. So very quickly, I just wanted to share some of the thoughts from the public that did come out of the ASR presentation that we did in February, and I'll try to go through them real quick. And that was regarding the benefits of ASR. There were comments to the effect like ASR won't have a huge benefit of taking the peak flows off of the estuaries, but could have an effect for water supply, and they want us to be transparent as to what the ASRs will and won't do. Another comment was one average of foot of the lake is 450,000 acre-feet of storage. When you look at that volume, it's nearly impossible to put that much shallow storage on the landscape, which is true, and that's in reference to what would be a surface water reservoir or kind of feature. And then another comment was that that we need a combination of solutions. The tool of ASR wells needs to be a part of the plan. SERP used ASR to take water when no other facilities could take it and recover when water was not available from other sources. It's a critical tool to make SERP work. Regarding the ecological risk assessment, and I probably did well, obviously yesterday I gave a very quick synopsis of the ecological risk assessment, but there was a recognition that the ASR regional study report did detail an increase in arsenic and impacts to aquatic invertebrates and the potential effects to aquatic flora, and there's an expectation that we'll be able to address some of those issues that were identified in the ecological risk assessment report. With regard to science, it was stated that there should be a clearly spelled out a plan on how to address the remaining questions about arsenic, bioaccumulation, mercury, sulfates. There is a lot of uncertainty with recovery volumes, ecological impacts, and there's a need to proceed with caution. With regard to the treatment technology, arsenic is a real concern in the aquifer and in the surface water upon recovery. ASR regional study indicates that arsenic is released and then subsequently precipitated in the aquifer during cycle tests. So water is in compliance with Safe Drinking Water Act. And there's just an overall concern about arsenic, just like Renee had mentioned about the treatment processes to address that. And then there was a question or a comment about trihalomethanes that would be released if we were to chlorinate the water for a treatment process, which we are not anticipating using. In fact, chlorine was not amongst the processes that were evaluated recently by Stantec. Ultraviolet disinfection is more expensive, and it does certainly avoid carcinogenic byproducts. But as also you saw, is that certainly at both the Hillsborough and the Kissimmee ASR system, ultraviolet disinfection was not quite as effective as we'd wished it would be on coliform inactivation in meeting the standards before the water went into the well. With regard to well clustering, there was a question about co-locating deep injection wells with the ASR wells, so that if the water recovered from the ASR wells were to have arsenic in it, would we have the ability to be able to not recover that water directly to the environment, but put the water into a deep injection well as part of the plan? And disposing of water. And so on one hand, there were many comments or several comments supporting the use of deep injection wells integral with ASR wells. And then there was diametrically opposing views that disposing of water via deep injection is removing water from the system that would otherwise be would be available and needed by the environment at some point in time. And then there's an overall concern, depending on using more and more water from the Floridan aquifer for drinking water supply. We need to be very careful about how the ASR wells might impact the overall water quality in the Floridan aquifer, because it is true. As in addition to my involvement here in the ASR program, I'm also in the Water Supply Planning Bureau. And what we do there is we look at the future of 20 years down the road in each of the areas of South Florida and the water supply that's going to be available to the public as our population increases. And there will be more and more usage of the Floridan aquifer in the future. So as we consider this ASR program, there will be more and more reliance on using the Floridan aquifer for drinking water supply. So certainly there's a note of caution about whatever we use the upper Floridan aquifer for. There was a comment about regulatory standards, and the public wanted to know, will we be using primary drinking water standards? Will we be always meeting primary drinking water standards, or will we requesting exemptions from drinking water standards? As I mentioned yesterday, for the pilot projects, we did apply for water quality criteria exemptions, so that we would not have to treat the water to secondary standards, such as color and iron and odor and those sorts of aesthetic standards. So there is general interest in the public about what kind of treatment processes we will use and what sorts of standards we will be meeting while we build these ASR systems. And subsurface geology, of course, it's not predictable. And there's general questions about how much water we will be able to recover as we do build these systems. So I just wanted to share them with you that clearly we've heard this overall perception of the ASR program, the overall public interest in the program, and these are sort of the comments of not necessarily the layperson, because the people that come to these meetings, they're engaged. I mean, the RAC members and the people that take the time to come to these meetings, they are interested in all of these questions. And so we do keep them in our forefront of our mind as we are implementing this program. So anyway, I'm going to open the floor. We actually have about an hour left. So I'm opening the floor now to anything that the panel wants to talk about, if in fact you have anything to talk about.
Bob, that was a great synopsis of the RAC meeting back in February, and I really appreciate this because looking at the video and listening to the depth of the questions, you're absolutely right. It was a seriously engaged group of people there, and not only on the RAC but in the audience, and some real good ideas that were put forth, and they make you really wonder. I recall one was just a simple question about why 5 MGD, why not 6 MGD, and that may be a cost benefit thing where if you move to that size pump, it's just not reasonable. But these fresh looks and these abilities to iteratively look at the overall picture and invite this feedback is powerful, and I really commend all of the SERP team for fostering that environment. The question I have, just in terms of a panel discussion, and this is, I was going to ask you, Bob, could you touch on the relationship between the EAA reservoir and ASR for us?
Well, the EAA reservoir, I wish I had a map. I wish I had a map to show you where that feature is located. But we're talking about the area south of Lake Okeechobee, and interestingly enough, there is not an ASR component to the EAA reservoir at this time. I have to say that I have looked at the Floridan aquifer wells that are south of Lake Okeechobee, and there are not that many. We really don't have a very great understanding of the Floridan aquifer south of Lake Okeechobee. But what I can offer you is this: the wells that are south, the Floridan aquifer wells that are south of Lake Okeechobee, are not that highly productive. I was asked to take a look at the potential for integrating ASR into the Western Everglades project that is also south of Lake Okeechobee. And I did do reconnaissance of all of the Floridan aquifer wells that are south of the lake as part of that effort. And the Floridan, it's really muddy south of the lake. There's not an awful lot of transmissivity, high transmissivity within the aquifer zones south of Lake Okeechobee. And my conception of the system is that in the interior of Florida during the Eocene of the Florida platform, all of the reefal features were on the margins of the platform. All of those corals and the rudists and the actual shelly aspects of the Floridan aquifer, it's mostly along the coastline, the edge of the platform. The interior of the Floridan platform was kind of a backwater area, and there's not an awful lot of high porosity granular facies within the area of the EAA itself. At least that's my conception of what the platform looked like 40 million years ago. So, and that's the explanation why I think there's not an awful lot of transmissivity observed in the Floridan, in that agricultural area. And that's why ASR has not been really integrated into the Western Everglades project, and that pretty much is consistent with where the area of the EAA reservoir is also.
John, I think another aspect of EAA is that compared to the north of the lake, there is a desire, in addition to hydrogeologic suitability north of the lake, there was the desire to capture the water before it gets to Lake O. The primary source waters for that will fill EAA A2 reservoir, the A1 flow equalization basin, and then treatment are from the Miami Canal and New River canals, which bound either side of this enormous complex of flow equalization basin, reservoir, and STA. So yeah, for hydrogeologic reasons and then just water conveyance reasons, I think EAA never really was, ASR was never really considered in the context of that project.
Okay.
Mm-hmm.
Thank you both.
And one other thought about that is that when you really look at the big projects that the South Florida Water Management and the Army Corps of Engineers are constructing now, when you look on the west side of the system, we're in the process right now of building the C-43 reservoir. That's a huge project, and it's a big deal. It's very exciting, and we're looking, I think, on completing the construction of that reservoir along the Caloosahatchee River in the next couple of years. And so we have a massive water storage project on the west side. The EAA reservoir south of Lake Okeechobee is massive, as well as the expansions of the STAs and the water storage components that we have south of the lake. We've got a huge projects that are online and coming south of Lake Okeechobee. On the east side, we've got the C-44 reservoir and STA that's under construction. That's an exciting project. We've already completed several of the components of the C-44 reservoir that's going to benefit the St. Lucie estuary. So we have some really big projects on the west side, the south, and on the east side. This project is the big kahuna north of the lake. This really is, in my view, the linchpin project. When we can complete this Lake Okeechobee project north of the lake, we will be able to better control the flow of water coming into Lake Okeechobee, and integrating this Lake Okeechobee watershed project with the other huge features that are already either in planning or halfway built already. We're gonna get there. We're gonna get there. I mean, I'm really actually optimistic that in the next 5 to 10 years, we're going to see some real improvements. I mean, I'm very much looking forward to seeing how all these projects link together, which is great because I plan on living forever.
You have to when you work on the Everglades.
Right. Geologic skills.
Bob, this is Tom Missimer. On the west side, particularly of C43, you only have one aquifer that has the capability of receiving a lot of water, and that's the Avon Park permeability zone. And it could receive actually there even more than 5 MGD at the high transmissivity it has, but it contains TDS of about 18,000. And again, I've shared some things with you about storing water in there on a longer term that would provide a water supply for the Lehigh Acres in Lee County, which has no future good quality water supply. So you could actually combine some of the storage facilities in the SERP process with creation of future water supplies in areas that are poorly planned. So that's something else that should be really considered in the overall scheme.
Yeah, I agree. I think that's a really creative concept. I hope that the Lee County can consider maybe trying to do a feasibility evaluation of that sometime in the future. That would certainly help the area of Lehigh Acres, which is projected, which is in Lee County, for those that are not aware, and it is projected to be a high growth area. That at this point, most of the water supply from that Lehigh Acres area comes from domestic self-supply wells that are completed in the surficial aquifer. And by using the Floridan aquifer and by recharging the Avon Park permeable zone in that area, would certainly benefit in the actual creation of a freshwater aquifer in a zone that, at this point, like Tom said, is a brackish water source and not drinkable.
Bob, this is Sam. What's being done upstream on the Kissimmee to intercept flow?
Maybe the best person to answer that would be Tim. Are you still on the line? Can you speak to us at all about the Kissimmee River Restoration Project? Or Michelle or Liz, are you closer to those projects?
Yeah, Bob, I'm on it. Can you repeat the question, please? I apologize.
Sam was asking about what projects are taking place along the Kissimmee River and within the Kissimmee River Restoration Area about water storage and water supply that are taking place as part of the Kissimmee River Restoration Project.
Okay. Yeah, and so where we are with the Kissimmee River Restoration and just kind of general overview of that, I think the intent is environmental restoration of the Kissimmee River and the floodplain area. We're currently working on the last 2 construction projects to complete backfill of C38, as well as what is called the S69 weir, which is the most downstream project feature at the end of C38 backfill, basically providing a solid end to the backfill and enables us to stage up water into the floodplain to historic levels to get that restoration. So all of that work is scheduled to be complete by the end of next spring. And time for the next wet season beginning in June next year. As far as specific storage, while the intent of the project is not to create storage, with the restoration of floodplain, you do expect to see stages of 2 to 3, if not 4 feet of water in the floodplain, which does provide additional storage within the system, also slowing down the timing of deliveries of water from the Kissimmee Basin to Lake Okeechobee. So there is a built-in benefit of storage. However, it's not what we consider long-term storage, as we would look at with an above-ground storage facility or with ASR wells. It's short-term storage, which mainly affects the timing of the water movement through the system. That's one big difference. So the other part of that, we are beginning the early stages of planning a Kissimmee-Istapoga Basin operations plan update. Many people may be aware we're currently undertaking a Lake Okeechobee regulation schedule evaluation and developing new plans for regulation of Lake Okeechobee. Once that effort is complete, we are contemplating kicking off a operations effort for the Kissimmee and Istapoga basins. And part of that would be to look at optimization of operations of all of the structures within the basin, which may provide seasonal storage within the basin. However, the extent of what that storage might be, I don't have a good idea of that offhand. However, there are limitations to what you can do with operations, especially when you're talking about the chain of lakes, due to the urbanization of that area. Flood risk management is always foremost when we're looking at operational changes, especially in more urban areas. So what storage could be affected from the system, in addition to what we already see with the restoration project, kind of unknown right now. However, I would not expect it to be on the scale of anything that we've talked about in the last 2 days related to what we would see with the Lake Okeechobee watershed restoration, just due to the amount of ASR wells and the above ground storage that we'll be creating. That's likely to be much bigger than you would see with any operational changes in the Kissimmee Basin. I don't know if that answers the question or if that was down the wrong path a little bit or not, but hopefully that did provide some background.
Yeah, that does. That, you know, with the increased urbanization up toward Orlando and St. Cloud and Kissimmee, you know, there's always going to be this increase in runoff with paved surfaces and so on, and you know, anything that could be done to intercept that water before it, say, gets to Lake Kissimmee would be a help to the Okeechobee system. So that's what I was kind of asking about. Thank you. Okay.
Yeah, you're welcome. And I think that is one of the things that we would look at in an operations study is how can we better manage the lakes, not only for environmental benefit, but also for water supply and flood risk management. Are there things we could do? Recall the system was designed under CNSF back in the 1950s. So it's been in place for a really long time, and conditions are very different than they were back then. So that would be a focus of an operations study, to see how we can modify things and try to positively affect the movement of water in the system.
Bob, this is Tom Mismer. Isn't it true that the district is actually actively raising the stage of retention stage of Lake Kissimmee by a foot? Because I actually was a consultant to the district on that issue.
I'm not really aware of what's going on? You're talking about Lake Kissimmee, Tom?
Yes, the district's been actively involved in changing the regulatory stage of Lake Kissimmee to add storage. And in fact, they invoked eminent domain and took about 600 acres of property of some of the farms around that area. So that's another storage issue in changing the regulatory pattern of water deliveries downstream.
Yeah, I'm not directly involved with that, Tom. So I don't know. Would Tim know anything about that, or Michelle? Are you aware of that?
Yeah. Sure, I can maybe address that, and if Michelle has anything to add, she can. But I think part of the Kissimmee River Restoration Project authorization was development of a modified, what's called the headwaters schedule for Lake Kissimmee itself. So it governed discharges at S65, which is the outlet of Lake Kissimmee. And part of the effort was acquisition of real estate around Lake Kissimmee to allow additional storage of about 1.5 feet. So what the headwater schedule does is change the regulation schedule from a peak of 52.5 entering the dry season to 54 feet entering the dry season, which is intended to provide environmental water supply for the Kissimmee River Basin, basically a base flow amount during the dry season. So that would add some additional storage capability to the Lake Kissimmee once the restoration construction is complete and the headwater schedule is implemented.
I wanted to also follow up on a comment that actually Renee made earlier yesterday that I wanted to follow up on because it was an intriguing thing to me that I thought maybe we could talk a little bit about. And that was a comment that Renee made about nitrogen species that admittedly we really haven't taken a real hard look at yet. Certainly we have already talked an awful lot about phosphorus and the capacity of ASR to reduce phosphorus concentrations. But when Renee asked the question about analysis for nitrogen species, I have to say that we've not done an awful lot of detailed evaluation on that. So I wanted to let you know that I really did actually hear that question, and it kind of got me on a track further talking about, algal blooms within Lake Okeechobee. And of course, we now have a task force. I think Tom Frazier is involved in taking a look at the blue-green algae and the toxic concentrations and levels of toxic algae within Lake Okeechobee. And I have to say that we have really not been able to make any or done any evaluation as to the impacts or potential benefits that ASR might have to algae blooms on Lake Okeechobee. I don't know, or don't recall at least, any direct evaluations that we've done to be able to make any kind of a statement definitively on the benefits or any improvements in algae blooms on Lake Okeechobee. And I think that might be, at this time, that's something that I think maybe we ought to try to take a look at. Not exactly sure what we can do, but maybe I certainly know that there's an awful lot of interest in that, and certainly been an awakening in the public eye about the quality of water and the potential for algae blooms within Lake Okeechobee. And I really don't know that we've done an awful lot of direct evaluations so that we can make some definitive statements about the implementation of ASR and what kind of impacts they could have on algae blooms within Lake Okeechobee. So I just thought I'd throw out that to the group for a little bit of discussion or thought before we yield the floor to the public.
Well, Bob, I don't remember sending you my notes yet, but you must have them. No, that's definitely on the radar, and I think on page 9047 of one of the documents you sent us, it does talk about the impact of ASR on water clarity and how that might affect algal blooms. But yeah, there's not a major representation, and that's, you know, that's a function of the amount of time that's gone by, and you know, various changes that have led to the situation today. And it's certainly an important subject that I'm sure you will hear more about from the peer team.
Great, thank you.
Thank you for bringing that up, Robert, and I'm glad to hear that you're thinking about it. And John is correct. You'll be hearing some more recommendations from us related to that. But I do think that the ASR has the potential, just by intercepting high nutrient water that goes into the lake, by reducing nutrient inputs, by intercepting that water right in the northern end. Before going into the lake. And maybe just even looking at nutrient concentrations in those canals now, not just phosphorus but nitrogen. Your suggestion of looking at data that's already available, right? And I know there's a lot of water chemistry information on nutrient concentrations in those canals. So maybe just looking at those values and maybe doing some calculations related to the volumes of water that you're suggesting of inputting into the ASR, of looking at fluxes of removing nutrients before they enter the lake.
Yeah, well, certainly that is available. In fact, yesterday at 3 o'clock at night when I woke up, it prompted me to actually dig back into the ecological risk assessment report that's part of the ASR regional study report, and I found some text on actually in the ASR regional study report on page 8-187, and that was with regard to. Remember, I showed you those periphyton studies, those glass slides that we put in the recovered water stream at the Kissimmee ASR site, and we put those glass microscope slides, and we allowed the algae periphyton to kind of grow on those glass slides. And actually, deep in the document itself, it looked at the recovered water influence on the periphyton community that grew on those slides, and there is a statement in there that there really was no difference in the community of algae that grew on the slides relative to the upstream and downstream locations, which was a good thing. But also, there was an analysis of the actual community of algae, the various representatives of algae species, I suppose, that comprised it. And they did make an observation that the community of algae did not show a shift in the toxin-forming population of algae within the periphyton on the periphyton samples. So, for what it's worth, it did not show that there was an increase in the cyanobacteria-dominated species as part of that analysis. So, for what it's worth, that observation was made in the ecological evaluation of the recovered water. But I think we have a lot further to go.
Well, Bob, I see we have some time. I think you wanted to open it up for questions at 11:30. There were some questions that were shared after the meeting based on yesterday's conversation. And I've taken all of the feedback thus far into those, major headings I mentioned earlier about, under the umbrella of hydrologic modeling versus regional considerations, geochemical, biological, well construction, and operational. And this question came from the committee, and so we're going to go from very high altitude down to extremely granular, but I didn't want to miss it. One of the team members asked, why did the open hole at Hillsborough site collapse at 330 feet?
The open hole at the Hillsborough ASR site?
Yes.
I have to say I'm not recalling that. Was that actually in the well completion report somewhere?
I'd have to defer to the team member who sent that question.
Hey, Bob, maybe they mean Caloosahatchee.
That's what I'm thinking.
Okay.
Oh, yeah. Okay, sure. Yeah. So when we constructed the exploratory well there along the Caloosahatchee River actually it was at the C43 reservoir location at Berry Groves, we were expecting that the upper part of the Floridan aquifer would be just like it is at most other locations. It would be a porous representation of the Swanee or Ocala limestone, and would be available for an open completion type of an ASR well. What we encountered was something of a unique facies, which when we drilled into the top of the Floridan aquifer, it was just a pile of beach sand, which is quite not common, at least for most of the ASR wells. We typically can anticipate that the upper Floridan aquifer is a very competent limestone, porous limestone that's very well cemented. So what we did encounter there was quite unexpected, and we actually we tried to drill through it, and every time we drilled through it, it's equivalent to like taking a shovel at the beach and trying to dig a hole at the beach. If you've ever done that before, you only can get so far before the beach just keeps filling in the hole that you're trying to dig. And that's exactly what happened while we were drilling through that formation. Is every time we advanced the borehole and we pulled the bit back up, literally the borehole just continued to collapse and fill back up again with totally unconsolidated fine-grained sand, which was really quite unusual, which is why you really do need to drill an exploratory well whenever you're envisioning doing an ASR project, so that you can make exactly that kind of assessment. And what we found is that area along the Caloosahatchee River, in fact, was a channelway of clastic material that represented an ancient river system that was flowing in that western area. Tom, I think you wound up doing a little bit of follow-up work on that fluvial system.
Yeah, and actually it is a beach system, Bob. So, and it goes the whole way around the margin. You find it in about 10 other places in Lee County, where there's about 50 feet of quartz sand in the Swanee. So, but the actual question is at the Hillsborough site in the monitoring well 330 feet away, there was a turbidity problem that in the report noted that there was some collapse below the casing. That was the question. Why
Okay. Yeah. I do recall that, actually. During the cycle testing at the Hillsborough ASR site, you're right. There's a monitor well that's about 300 or so feet away from the ASR well. And yeah, that open borehole did in fact collapse during the cycle testing at Hillsborough. We went back one day, and all of a sudden it had filled in with unconsolidated material, limestone and sand, and it was really a very unusual occurrence. We went into the well to try to figure it out, and it's a very narrow diameter monitor well, but we did run a video camera down that well. And as it turns out, the borehole did in fact collapse, and there was only a foot or two of open hole left beneath the well casing on that well. But I don't really have a mechanical explanation as to why that happened, and it does happen from time to time on the on open boreholes. As we learned, the L63N Canal ASR well had also backfilled with material over the years. Boreholes do become available, and sometimes they just sort of give way when they're open and slough off into the borehole and backfill it to some extent. But no, I don't have a better mechanical explanation for why it did that than that, Tom.
Hey, Bob, another question that came in was relating to closure of ASR wells, and I guess that also gets to lifespan. But if for some reason a project runs out of money, and what's the plan for mothballing or permanent closure, either midlife or end of life?
Well, we actually have to plan for that as part of the permitting process. When we do a UIC permit for an ASR well, it's a requirement that we actually prepare a plugging and abandonment plan as part of the permit application process. In the event that a well does need, in fact, to be closed and abandoned. We have not gotten to that point at any of our ASR systems yet, but we do understand and know that at some point in time, if an ASR well becomes inactive to a point where it does need to be plugged, we do anticipate that we would need to backfill the open hole with concrete and essentially fill the well up, backplug the well entirely. So that's always anticipated. We normally, before we take that big step, before we actually decide to truly abandon the well, what we try to go through a decision process is, could that well at least be left as a monitoring well? When we talk to our groundwater modelers and we try to calibrate our regional models and water quality networks, we hate to abandon wells in the sense that if a well can ultimately be used as a monitoring location so that we can more intelligently calibrate our groundwater models, then certainly the well does have some value as if nothing else, a monitoring station. So that is normally taken a hard look at before we actually go through the step of abandoning a well entirely. I mean, they're not cheap, right? I mean, these wells cost, even a monitoring well costs anywhere between $250,000 to $750,000. So we are, we've got a substantial capital investment. When we ultimately make the decision to drill a well, we really do consider the value of whatever that location is, and even if the ASR well itself could not be used, we would certainly look long and hard to at least using it as a monitoring well before we took that step. But that step is always in the game plan if we have to go there.
All right, thank you. Any other questions from the peer review team?
Okay, so at this point, we're just about coming up on 11:30, and just like yesterday, I know that the public has been listening in. As I see right now, we've got 67 participants on the at this Zoom location. So I really do thank the public for listening in on all of this, and wanted to, if the panel is open to it, leaving the floor to the public to provide some comments on what they've heard today and as of yesterday.
Absolutely.
So, okay.
You already have a hand up.
Yeah. So, Devon, are you there?
Yes, I'm here.
Okay. So we're going to open up the floor to the public now, and field some questions and comments to the public. One thing that I failed to mention yesterday was one or two things. We don't know how many people want to say anything, so please limit your comments and questions to no more than 3 minutes, and also that the panel itself is not expected or should plan on having to directly address the question or comment. We're here to listen to the public. But the panel itself will not be responding to questions per se. So we do welcome your questions and comments, but the panel will not be responding to them directly. So with that in mind, why don't we open the floor? Tom Van Lent, I see you're there.
Yes, thank you. For the record, my name is Thomas Van Lent. I'm an engineer and hydrologist with the Everglades Foundation. And I just wanted to take first the opportunity to thank this panel for agreeing to perform this peer review. It's extremely important to the Everglades restoration process, and any involvement is welcome. And so, thank you. I too have been at this quite a long time, and if I was just to take this from a overall perspective, I would say that when SERP came out in 2000, ASR was the focus of a lot of scientific controversy, and you kind of alluded to that, a lot of basic questions about the application, not of ASR technology, but its application in this context for flood control and environmental restoration. And the Corps and District went back and formulated a research plan that was reviewed by the National Academy in 2002. And the end result was the ASR regional study, which came out about 12 years later in 2014. And that represented an enormous contribution to the state of understanding. And you saw that yesterday. It was like drinking from the proverbial knowledge fire hose, and even the tip of that knowledge iceberg is still very impressive on how much work was done, a lot of great work by a lot of dedicated scientists. But that was reviewed in 2015 by the National Academy of Sciences. And it was an excellent review, and the National Academy has a lot of credibility. Thank you to Dr. Price for being on that committee. So what we were kind of expecting is that the project plan for aquifer storage and recovery, this implementation, would address the concerns raised by the National Academy in that review. And it's pretty long, and I'll just focus on a couple. For example, the risk assessment that's in the regional assessment or the regional study was a lot of recommendations on how to improve that. Two, its application in the context of flood control and environmental restoration. And that's important. I think it was Dr. Arthur who mentioned, well, for example, in the simulations done, that there's two important assumptions. One is that the aquifer volume is essentially infinite. And that's interesting because as the simulation period grows, so does the size of the bubble, so to speak. And two, the assumption about recovery rates were roughly 50% effectively. The benefits and results depend strongly on those two. I think Dr. Arthur mentioned it. Well, if the bubble is bigger and it encounters more arsenic, that is then added to the ecosystem. We've seen arsenic bioaccumulation in freshwater mussels. So the National Academy asked the question of, well, do we need operational limits? We need to revisit some of these assumptions. Do we need to operate it differently than what we've assumed? That means that the benefits you saw presented, which depend on those assumptions, may change, as they did when the full evaluation of SERP did by the regional study. Second, the costs of alternatives, especially this treatment train, is really important because an alternative is only relevant with respect to what other alternatives do you have. So we're very much expecting a science plan that accompanies this project implementation that addresses these major uncertainties. But it was full of information. For example, I was very interested to see the proposal of rehydration of Paradise Run. That's exactly the kind of thing that this project should be doing. But the science question should not be, is adding water to a wetland a good idea? But what's the effect of adding ASR water to this wetland? So the question we'd ask the peer review panel is this scientific experiment that's proposed going to answer the question of what happens when we add ASR water to a wetland? So is the science designed correctly? So we have, if the science plan is available, I'm sorry, I haven't seen it. I tried to see if the district had that yet, but then we can give very specific technical comments and input in a constructive and helpful way. If I was to make recommendations to the committee, I would say go really back to the National Academy report, contact Dr. Johnson from the National Academy and the Dr. Sayers, who was the head of that. Unfortunately, you have Dr. Price, who was on that committee, but they lay out in a very, very careful way what we need to address so we can determine whether or not whether ASR works, but whether ASR works in this context of flood control and water supply, and what do we need to do to make sure that it's safe. So thank you very much for your attention, and we look forward to this process as it unfolds. Thank you.
Thank you, Tom. Nyla?
Afternoon. I believe it's afternoon. Well, maybe not. Nyla Pipes, One Florida Foundation. I know I spoke on this yesterday, but I just wanted to reiterate that once again, you know, with of the in-depth conversation that happened yesterday and what you've shown today, you are absolutely doing that homework to show us all that this is going to work and how it's going to work. And even more importantly, you're showing us the areas that we still need to know a little bit more. And I just want to say, I think it's phenomenal, the work you guys have put in. I especially like that you referred to this as an ongoing relationship, as opposed to treating this as one peer review and okay, one and done, and we know it's all good. I think that relationship is going to be the key to the entire thing. And I just want to end by saying this is not an experiment. This is not unproven science. This is ongoing science. And that is a really important distinction. So we've got to keep moving forward because, as we all know, SERP has always planned for these. We know that we've already lost some of the original plan for the use of ASR wells in SERP, but we have to be able to adjust as we get more of the questions answered And this is absolutely one tool in the toolbox, the use of ASR and possibly deep well injection as well, to go ahead and handle the fact that over 50% of what was the original Everglades has now been moved into, developed, and utilized by humans. So whether we like it or not, technology is our way forward. And I just want to reiterate that this has been a fantastic couple of days looking at the science that you all are doing. Thank you.
Thank you, Nyla. Anybody else? I see Scott Dyer.
Am I unmuted?
Yes, you are.
Okay. My name is Scott Dyer. I represent as a PG1 the Florida Geological Survey. First and foremost, I'm blown away. I'm amazed at the minds that have come together and the work that's been conducted. I'm experiencing a research overload, and I aspire to have the capabilities of those that have gone into such depth and breadth with this project. I've got a kind of a fundamental question going back to some of the panel discussion we just had about north of the confluence of the Kissimmee, which I guess is now a canal, and Lake Okeechobee. I'm a little bit confused as to whether ASR primary objectives are more to deal with floodwater and stage control from waters that are, flowing south toward Lake Okeechobee, or equally possibly, if the second or paired objective would be to capture that water so that we can retain it to meet our future water demands that we will need. And where I'm going with this now would be focusing on the water that is moving down the Kissimmee and becoming more of a stage issue, flood aspects. And I'm wondering how much the Central Florida Water Initiative group, I'm not sure of its actual title, but it's the Central Florida Water Initiative, how much coordination or input have we sought or do we have with them as far as trying to control a lot of the water that would be, mounding up and causing a problem for Lake Okeechobee? Because I wonder, and this is a very rude comment, but I wonder if Lake Okeechobee has become kind of a stormwater pond for the counties, municipalities, so forth, the population north of it. And if we're going to maybe seek their help on limiting the flow of water that is being shunted or pushed down to the southbound neighbors and environments. And if there's possibly opportunities to rehydrate areas that aren't necessarily planned for any urban development, so that the ASR program doesn't have to deal with so much previously polluted or shunted or stormwater. So that's just the topic. I really don't expect an answer. It's just something I was wondering about and would like the panel or others to think about. What kind of, is ASR project dealing with other people's problems? And if so, can you seek some help from those upstream contributors? Thank you. I admire you all. I appreciate the edification I've received the last couple of days.
Thank you, Scott. Melody?
Hi, this is Melody Naja from the Everglades Foundation. I am a water quality scientist. I would like to follow up on Tom Van Lent observations. And first, I would like to congratulate the district on this workshop. Yesterday and today, it was very informative. The data collected, the analysis were really very informative. In my opinion, the work of this panel is essential to address the uncertainties raised by the National Academy of Sciences when they reviewed the ASR. The work of this panel is essential to build on top of the National Academy of Sciences work and not to reproduce the National Academy of Science work. The public is eager to hear about research methodology, research design to address the specific questions about the ecological and water quality risk assessment. In my opinion, I would like to see, for example, a methodology developed to quantitatively address and assess the ecological and the ecological risk assessment, and to basically to be able to weigh in the benefits and risk of implementing ASR at a large scale. There are specific questions that come to my mind now. Is like, what happened to the arsenic if the district moves and implement a treatment technology to reach a secondary water quality drinking standard? What are the ecological risks if we use ASR to rehydrate Paradise Run wetland? Is the recovered water from the ASR marsh ready to rehydrate a wetland? These are specific questions that we would like the district to develop a methodology, a research methodology to address. Thank you.
Thank you, Melody. Anybody else from the public? Grant, we see your hand up.
Okay, can you hear me? Can you hear me now?
Yeah, can you speak up, Grant? We can barely hear you.
Okay, is this any better?
Just a little bit. Go ahead.
Okay. Yeah, thanks for the presentation. You guys did a great job. There's a lot of great information in there, and I really appreciate all the work that went into this workshop. Some of the concerns that have been spoken about the National Academy of Sciences. I see in the press release on the 29th of April from 2015, they said that the committee agrees with the ASR regional study findings that no fatal flaws in the ASR have been discovered. So there are no fatal flaws with the ASR, and I'm not sure I quite understand all the pushback against at least going forward with trying this technology. This technology has been used all across the nation, even out like in Monterey, California. I was out there earlier this year, and I found that they had ASR wells. And California, as you know, they're very strict on environmental regulations. And if California can find a way to make ASR technology work and meet their particular conditions, I'm sure that we could too. So I just want to put that out there, and I think it's a great thing that we could try, and I think it'll work. Thank you.
Thank you, Grant. Anybody else from the public? Okay then. Well, we certainly appreciate you you all speaking up. We've certainly heard you and are documenting your comments and questions, and have every intention of trying to address each of these thoughts. So we really truly do appreciate it. With that, we've actually finished up a little bit ahead of time. Did John or any of the panel members, would any of you like to have any closing thoughts or comments before we finish up for today?
This is Sam Upchurch again, and I start off by thanking everyone for their input. This has been a great 2 days. The reason I'm talking though is John, Arthur, we need to talk about deadlines for getting feedback to you so you can put your summary document together.
Yeah, Sam, I was going to communicate via email on that and take advantage of this wealth of information that's fresh in our minds, as well as all of the reading we've done in preparation. So you'll hear from me shortly. Any other members of the team? Well, Bob, I guess, and just to wrap up, I do also appreciate, again, all the presentations as well as the public comments. And we look forward to diving in even more so with regard to our charge as a team. And I just, want to speak to, early on at the beginning of this, when you outlined our charge and the materials we were given to read, of course, one of those was the National Academy's report of 2015. And we did not talk a ton about that during the past 2 days, but it's certainly on the radar. I just want to reassure folks. And under the grand umbrella of uncertainty reduction, that's certainly on our radar. And while there are no major obstacles at present that have been identified, I've noted that it's just part of the conversation and philosophy that there will be careful progress forward. And whether it was a meeting I was in 2000 or 2001 or 2005 or today, the concept of adaptive management throughout this process it's just a way of eating, breathing, thinking, and I think that's an essential component for something so large, because this is a massive system, and a system of systems, if you will, but integration of all of these different things is a tremendous task. The derivative benefits and the good science coming out of it is going to be tremendous as well. And I think it's real important to have opportunities through some kind of feedback loop or an opportunity to pause and evaluate and make sure that everybody who needs to be talking is talking. And that will be a piece of recommendation. You'll hear more from us, but anyway, I'm just very grateful for the team that's been assembled, for the presentations, and thank you. Back to you.
Okay. Well, thank you, John. I certainly appreciate it. The team and the panel and all of your thoughts and comments. So at this point, coming back to the scope of work for the panel, we certainly look for your recommendations and thoughts on moving forward with a science plan that we can use to address the various questions that come at us and have come to us as we implement this ASR program. So we're looking forward to continued dialogue. We will revisit. We will visit again when we hear back from the panel on their thoughts and recommendations as to ways that we can move forward with addressing these scientific questions. And I look forward to working with the panel and the public as we roll out this ASR program. So I appreciate everyone taking the time to attend both yesterday and today. We really do value this, and we are totally trying to be transparent as we move forward. That this is a continuing dialogue amongst us all. We're all working here. We all live here in South Florida and are trying to do our best for the environment and the ecology. That's why I'm certainly here at the district, and I'm sure everybody else is that I'm speaking with about our team members and the Army Corps of Engineer members. We want to be smart about this, and we certainly intend to continue working on a smart science plan. So thank you all for participating and attending, and have a good day. Take care.
All right, thanks, Bob. You too.
All right.